Greetings. Mr. Lee here. Alright, so this video is going to be on standard 11, which is the graphs of your basic sine and cosine functions. Okay, so these are the function equations. Y equals sine of theta, y equals cosine theta. Okay, so we're going to see how we graph that. We're going to use the help of our unit circle reference. Okay, so if you look here, on the x-axis, we have the angle measure. It's going to be in radians. You can also think of this as like x, right? Sine of x, but the important thing is you're doing sine of an angle measure, okay? And we know the sine is going to be related to the y-coordinates. X is related to your x-coordinates, okay? So when we're finding the output, which is the y values, right, we're going to look at the y-coordinates of these points if we're doing sine, or we're going to look at the x-coordinates of these points if we're doing sine. Sorry, if we're doing cosine, okay? X-coordinates for cosine, y-coordinates for sine. All right, so let's do sine first. I'm going to switch to a table view first. So if my function is y equals sine of x, I'm just going to show how we get a few of these points, hopefully help you guys visualize where you're actually plotting these points. And then I'll go back to the unit test screen and show you fully. Okay, so let's start with 0, right? If x is 0, right, it's just like we're doing an equation table graph. If x is 0, in other words, if your angle measure is 0 radians, the sine of that angle, sine of 0, should be the y-coordinate, which is also 0. So that's our output, 0, right? Angle measure 0, output is 0 because the sine of 0 is equal to 0. Okay? Next one, pi over 6. The sine of pi over 6, if my input is pi over 6, the output should be the sine, which is the y value, 1/2. Okay, we know 1/2 is equal to 0.5. I'm going to start using decimals because it's going to help us graph it a lot more accurately, in my opinion. Okay, next one, pi over 4. If x is pi over 4, the sine of pi over 4 is the y-coordinate at this point, root 2 over 2. Okay, so root 2 over 2 is about 0.7. We're going to start using that. Okay, it's okay to round a little bit. Next one should be pi over 3. Sine of pi over 3 is going to be the y-coordinate at this point again, root 3 over 2. Okay, root 3 over 2 is going to be about 0.9. Okay, we're just going to round it to the 10th place, 0.866, but about 0.9. That should give us enough accuracy to see the whole sine curve. Okay, let's just do one more for good measure, pi over 2, but I think you guys get the hang of this, right? Pi over 2 is over here. What is the y-coordinate there? What's the sine of pi over 2? It's going to be the y-coordinate here, 1. Boom. Okay, and then as we know, numbers are going to repeat, right? Root 3 over 2, root 2 over 2, 1/2, 0, then the negative versions of that. All right, so I'm going to leave this unit circle reference, and your job is to know exactly where I'm referencing. If I'm still on sine, I'm talking about the y-coordinates. If I'm talking about cosine, I'm on the x-coordinates. Okay, so let's go back to this unit test screen. There we go. And let's start graphing. Okay, so if it helps, you can, create your own table and then add the points in, but I'm just going to start using the unit circle reference, right? So the points we had were 0, 0, right? Because the sine of 0 is 0, right? I'm just going to start showing all these. I'm going to move my cursor to show you guys all the references, right? Sine of pi over 6 should be 0.5, so about there, all right? You want to graph it as accurately as you can. It's halfway from 0 to 1, right? That's your 1/2. Root 2 over 2, root 3 over 2, we said this was 0.7. Let's write that down, all right? Root 2 over 2 is about a 0.7. And then a root 3 over 2 is about a 0.9, right? We calculated that earlier. Okay, so at pi over 4, we should get root 2 over 2, which is 0.7, probably around there. Okay, at pi over 3, we're getting root 3 over 2, which is 0.9. So really close to 1, but not quite. And then we finally reach 1 at pi over 2, like that. Okay? So I'm going to keep going around this unit circle. You need to follow the y-coordinates right now, right? It's going to be boom, 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 right? Y-coordinates. Okay? Sine of 2 pi over 3 should be root 3 over 2, which is a 0.9. Sine of 3 pi over 4, root 2 over 2, which is a 0.7. Okay, you'll start seeing a pattern here as well. Sine of 5 pi over 6 gives you a 1/2. So about there. And then back to 0. Okay? So this is a video. I'm going to graph the rest of these points. But again, we're following your next angle over, and we're getting the y-coordinates for your sine. Okay? Pause it if you need to. But I'm going to be going a little bit quicker here. So 7 pi over 6, sine of 7 pi over 6 gives you negative 0.5, which is negative 1/2. We're at negative root 2 over 2. Negative root 3 over 2, which is negative 0.9. We should be pretty close to negative 1. We finally reach negative 1 at sine of 3 pi over 2. Okay. I'm going to go back to negative 0.9. Negative 0.7. Sine of 11 pi over 6 gets you back to negative 1/2. And then sine of 2 pi gets you back to 0. Okay, so we should see this sine curve. Okay, there's 2 more angles over here, which is good to know, your negative angle reference. We have to go clockwise now from 0. So if I go clockwise, a negative pi over 6 is this position. It's the same position as 11 pi over 6, right? We have to go pi over 6 clockwise, which just gets us to over here. Okay, so the sine of that value is negative 1/2, so negative 0.5. Try to match this as close as I can, probably around there. And then negative pi over 4, right? Instead of going positive pi over 4, we go negative pi over 4. Same position as 7 pi over 4. And then our y value there for the sine is negative 0.7, right? So about here. Boom. Okay, so I'm using a mouse, but you guys can then connect this as best you can with a smooth curve. It should be curved, okay? Common mistake. Some points were taken off for some of you guys if I saw like straight lines, okay? It's definitely not a straight line. Okay, you want to curve this as best you can. There should be like these peaks and valleys, a little bit of a hump type of shape, okay? Oopsies. All right, so that's sine. We're going to use the same thought process with cosine now. Okay, same process with cosine. I'm not even going to show you the table, but we're going to use the same process. I'm just going to go around here. Instead of extracting the y values, we want the x values now. Right? So I'm going to use the same angle measures. I'm going to start at 0. I'm going to work my way all the way to 2 pi. But I'm going to look at 1, root 3 over 2, root 2 over 2, 1/2, 0, right? X values. As I'm moving the next angle over, I'm just extracting that x value because it's the cosine now, right? So at an angle measure of 0, right? If theta is 0, or if my x value is 0, my cosine value starts at 1, right? Right here, x value of 1. And then it goes to 0.7. Sorry. Then it goes to 0.9. Then it goes to 0.7. Then it goes to 0.5. Right? Root 3 over 2 is the 0.9. So then it goes to 0.9, which is pretty dang close to 1. 0.7 is about here. And then 1/2, right about right there. Back to 0. Back to negative 1/2, 0.5. Negative 0.7, negative 0.9, negative 1. Okay, so I think you're getting the idea here. I'll narrate just a few of these. Okay, so if I'm at cosine of 4 pi over 3, cosine of 4 pi over 3, let's just get a reference here. we're over here, right? Cosine of 4 pi over 3, we want negative 1/2. So we're at negative 1/2. Okay, back to 0, back to 0.5, back to 0.7, back to 0.9, and then back to 1. Okay. So again, this is a video. Take your time. Pause it if you need to. Make sure you know where each of these values are coming from. Let's go 2 more, and then we're done. Negative pi over 6, going to be this position, right? X value there is a root 3 over 2, same thing as 0.9. So then we're over here. You could also follow the pattern, right? If this is going over there, gets to 0.9, and then back to 0.7. Negative pi over 4, same as your 7 pi over 4 position. X value is a positive root 2 over 2. Okay? So again, best you can, you're going to connect this with a smooth curve. It should be a curve, not a straight line, and then you're done. Okay? So let me just do my best to kind of connect these. I have a mouse, so it's probably going to be horrendous, but right, the idea is you should be connecting it. Oh, that's not too bad. I messed up there. That's okay. All right, and then the cosine will be like this. But notice how it's a curve, okay? Not a straight line. Okay, you will do a better job, obviously. So there we go.